AWS AI and ML Beyond the GenAI Hype Train with Vivek Raja PS, with AWS ML Hero Vivek Raja PS. Good evening, sir. How are you doing tonight?
I'm doing great. How are you guys?
We are doing good. We are vBrownBag, and we are here tonight to talk about the Gen AI hype train. If y'all are in the studio audience and you want to get in on the conversation, we will be paying attention on social media at vBrownBag, on YouTube, LinkedIn, Twitter, and Threads. Is it Thread? Yeah, it's Threads. Yep. So please feel free to join in on the conversation. With me this evening, I have my wonderful co-hosts, Damien and Shala. How are y'all doing tonight?
Shala, you go.
Okay.
Yeah, I'm edutainer.
Oh my goodness, I'm doing fine. I've been fighting with Terraform for the past couple of weeks.
Fighting with Terraform. Tell me more. I have a vested interest in this.
It's how to explain it. The best way to say it is I realized I end up having to get really creative with Terraform and what I'm terraforming. And that means figuring some stuff out a lot. But once I do, it's like really awesome. But yeah.
I saw that you have your Cloud Theft Auto. I can't say Grand Theft Auto because then we'll get struck for Cloud Theft Auto. What are you calling it? I forgot.
I called it Code Theft Auto.
Mm-hmm.
So what that is, for anyone who's interested, is how I taught myself Terraform. One of the intro videos I showed jokes about it's a joke, like in a jokey manner, but in all seriousness. Basically, I had to learn Terraform really quickly to actually put hands on keyboard and Terraform stuff for work, so I did not lose my job. So I came up with a workshop for myself that, now I'm the Terraform person on my team, along with the DevOps person on my team, which I think is hilarious.
That's a bit of you were never in danger. We're talking about your current position, right? You were never in danger of losing your job.
No, but I always look at it that way, where when I get tasked with something, I always have to try to give 100%, put my all in it. And notice I don't say 110% because there's only 100% of myself to give,
Oh,
so
I agree.
Yeah.
And Mr. Carlson?
Yeah.
It's been a couple of weeks. I was off on my little vacation. So what have you been up to?
I would be remiss if I didn't say that every day without you was like not having the sunshine.
What a load of crap. Oh my gosh.
You are the wind beneath my wings, Chris. And that's okay. Oh. That's okay because it's a very tall wind, very tall wings. It works. I'm doing really well, thank you. I actually had a really great time hosting and being a co-host a couple times as well while you were gone. Got to do editing, which was fun. But yeah, things are going really well. So thanks.
Awesome.
I'm excited to learn about what Vivek has to tell us today.
So what a fantastic segue, Damien. It's almost like we've practiced this.
Oh, indeed.
Vivek, before we get into it, tell the audience a little bit more about yourself. You are an AWS ML hero. So obviously tonight's talk is going to be fascinating for a number of reasons, but let's learn more about you.
Yep. So hi, everyone. So first of all, I'm a vBrownBag alumni. So I've been already in vBrownBag a couple of months, I should say, year. So So this is the second time I'm getting featured here. And what I do in my day-to-day job, I'm a VP of product, and I build some cool stuff in my work. So what I do is I build a helmet that could capture your brain waves and that could read your thoughts. So sounds scary, right? So yeah, besides all this GenAI hype, I'm putting out a new word here. So I'm building some neurotech here where I'm building brain-computer interfacing devices for neuroscientists, researchers, and stuff like that. So it's more like we are a competitor for Neuralink here, and that's what I do for my day-to-day job. And besides that, I do a lot of community events. So I lead a user group in my hometown called Madurai, that is in the south of India. So I've been running that for past couple of years, and we have also won Invent and Simplify Award in the APAC Community Leaders Summit, which was held in Thailand a couple of years back. And I was also a machine learning hero. So I think when the machine learning hero was awarded, I was 21 years of old at that time. So I had a couple of research papers in my hand, couple of patents. I used to be active delivering sessions, writing blogs, participating in hackathons, creating workshops and stuff like that. So that's pretty much about me. And yeah.
Amazing. So I have to ask before we get into the presentation, you're a competitor for Neuralink. So are you doing in vase? Is it like inside the? Are you when you're doing the brain pattern scanning and the I'm going to say mind reading. I know it's not mind reading, but is it like a chip inside the brain, or is this like on the surface and you're wearing a helmet that reads things, or a little bit of both, or what?
Yeah, it's a non-invasive, so it's like a helmet
okay.
which So we are on head, and you can control the electrodes how you want to move it, and you can have the complete tech stack. So which means if you write one single piece of code that whenever I am feeling sad, write a couple of Python logic to talk to Alexa. Whenever the brain dips into sadness, you will be able to do that with just 10 or 15 lines of code. So I made it that simple for everyone to access your brain data.
Okay, I'm a big proponent of non-invasive. When somebody says, "Oh, we're just going to drill a little hole in the side of your head and then put a wire," I'm like, "Nope, I'm out. Cash me out."
Nope.
So what does it look like? Because I really think it should look like Charles Xavier's helmet, Cerebro, where it's got wires and stuff.
Yes,
awesome.
pretty much like that. So it looks a little bit bulky because it has processors running inside the headset itself. So everything, the data and the processing, everything remains inside the headset, and you don't have to even connect to internet to work with that. So
cool.
Wow.
So it looks a little bit bulky, but we are actually, it's a first product, so we are down the line, we may make it much more sleeker, much more comfortable in future. Yeah.
Okay. Well, before we get into all that line of questioning, do you have a presentation? Was there a screen share that you wanted to share? Okay, let's get that put up, because otherwise I'll just ask you about brain scanning things from bad 1980s sci-fi stuff. All right, I'm going to remove this. There's all of our heads. Hey, everybody. Howdy. And I'm going to add this. All right.
All right. So today, there was a couple of ideas which I had, which I wanted to present to the vBrownBag audience. And then I decided that we have been talking a lot about GenAI, like past couple of months or past 2 years, it's always about generative AI. But there are few services, or there is something which is also happening besides generative AI. And that's what is going to be the focus of today's talk. And before we go into that, I really, really want to emphasize that why generative AI is in the hype train. What is the reason behind it? And why do people love it so much? Why do organizations love it so much they wanted to put it in spotlight in every single talk? So we will discover all that information. We'll find some answers to all the questions. And then we'll also see what does AWS have besides generative AI services. So that will be the agenda of today's talk.
Excellent.
So, yep. So as I said, we'll revisit the machine learning suite, and I'll also take you to a little bit about data processing, 2 deployments in AWS. We'll see what we could actually do with that. So a little bit about me, we already said something which I might miss. Yep, I'm also a Guinness World Record holder, and a VBB alum, which I've already mentioned. So this year's 2024 reInvent, I'll be there. This is going to be my first reInvent, and the best part is I'm going to be a speaker as well. So if you're planning to attend reInvent, you can make sure that you can add this session to your agenda, and I'll be happy to see you in the crowd.
This is going to be your first reInvent?
Yes. So I didn't get my US visa, and I had missed 3 reInvents, so that's pretty bad.
All right, we'll make this one special for you. When we go to the Hero Night, we're going to have some fun.
Wow, great! Looking forward for that. So I think this might be a little contradictory.
Oh, sorry.
Right?
No, I was just gonna call out. Sorry, I was just gonna call out. So it'll be your first reInvent and also your first time speaking at reInvent. That is amazing.
Yeah, that's pretty great.
Congrats.
Yeah.
Go Vivek.
Thank you so much. And the contradictory part is that today's talk is going to be the focus is not on generative AI, but my reInvent talk is solely based on generative AI. Yeah, but anyways, good to go. So yeah, how did it all start? Like, yeah, I got featured in vBrownBag a couple of years back, and it was we were just reeling out of COVID at that time, and I had a fun project in AWS where it reminds you to wear face masks from time to time. So that was a whole the project was about, and I wanted to present it to the vBrownBag audience. And we met, Chris and Aaron Hunter and me, we all met it at AWS Hero Summit, and it was like, I think I should really come back to vBrownBag sometime, and this is how it all started again. Yeah.
From humble beginnings. Look at us. How far we've come.
So let's go back to what's a hype cycle. So this is something which is put out by Gartner, and which says a couple of phases which really comes throughout the time. So when a technology is actually put out to the world, it triggers a lot of stuff, like a breakthrough happens, like some sort of an innovation which really happens, and it really grabs a lot of attention of masses. They try to ask a lot of questions, what it does and what is about to do and everything. And during this technology trigger, you don't really have a product or you don't really have a commercial aspect of it. It's just that a concept or even a research concept that is quite famous, and no one knows how it works, why it works, or might not be even proved at that time. And over the time, it inflates the expectations to another level. Like, people started to talk about it, the media tried to cover about that, and people try to actually push the limits of what is the reality of what the technology can really offer. And this over enthusiasm is actually has inflated a lot of technology, and with some companies and some projects try to do that, and it eventually most of the companies try to fail in this current phase. And next comes one of the very, very dreadful phase, which is the draw of disillusionment, and which is where all the excitement fades off. Like, people see that it might offer a very little to few value to the world or to their life, so they don't really try to invest much into it. And this is where you see that the interest, the investment, and all the things gets reduced, and companies really, really struggle to really build a viable use case and or to build some practical applications around that. And over the time, then we try to build something around it, and that's where we have a slightest hope, beacon of light, and that's where the hype dies. Really, the hype dies at this phase, and you get to see what this technology really has to offer. So the technology tries to transform the companies which remain invested all through this phases really see some benefit out of it. Like, they convert the failures into real successes. They really meet the expectations or the reality aspect of it, and they bring something valuable to the people or to the crowd or whoever it is. And that's when the last phase reaches, where it becomes one of the integral part of our lives, the consumers or businesses or market and everything. And it really brings some value addition to everything that we speak about. So this is how a hype cycle really works. And right now, people are riding generative AI in some sort of a phase. We will see where it is right now. This was something which was released in 2024, which was about the AI technologies which was coming around. And I know, like, wherever you go, like whether you go to your conference or you strike a conversation with your tech bro, everyone starts talking about generative AI. It's always
Yep.
about it, right? And that's crazy. Like at one point of time, it's a little bit annoying as well. So though I've been working on it quite a while, but it's annoying at sometimes. I understand. And the folks who have been not into AI or not much involved in AI, they see that okay, this has been shoved down to the throat to a very unusual level. So that's crazy. But anyways, companies try to remain invested in that cycle. That's what happens. Now, if you really wanted to take a look at this hype cycle for AI for 2024, um, let's all ignore what's happening in the innovation trigger. But if you just focus on the inflated expectations, the generative AI is in the verge of between the inflated expectations and it will soon go into disillusionment. So that's where we are really right now at the time. And the people have been also already having a hands on how to play with generative AI. They have been trying to build some use cases. Companies have been trying to put this feature in every single way that you try to interact with them. And I understand that it has really good some potential, but now it started to face some confronting issues. Like there are a lot of ethical concerns. It gives us misinformation. There is a lot of hallucination. People try to see how they can actually scale for better use cases. And right now, people are actually evaluating it to another level whether we need to implement this or not, or go for a better solution. So soon, maybe in interest of time, we might see that the generative AI hype might fade away in next couple of months or something. So, what do you think, guys? Like, do you think this hype would fade in a couple of months, seeing the cycle?
Well, I've been at this for a long time, and I've seen a lot of hype cycles and troughs of disillusionment in my career. So from this graph, are you saying that AI still hasn't gotten to the trough of disillusionment? It seems like most of the stuff is still in the peak of inflated expectations.
Actually, not. So there are few domains of AI which actually have matured. So if you take computer vision,
Yeah,
it has
CV.
been right now, CV is really part of our lives right now.
Yeah.
But the things of like the neurotech AI, which is not really much into the phase, or if you see the other stuff like autonomous vehicle, so things have been like we have criticized self-driving cars to another level, but right now it's starting to become part of our life. So one of
Mhm.
my friends who was in SA a couple of weeks back sent me a video that he was part of a passenger of a driverless car, and
Mhm.
for me it was really fascinating to see. So I think it's there is a lot of domains which is trying to get mature, but I think we still have to give some time.
Oh, well, I totally agree. Actually, I think somebody recently said something that kind of resonated with me to this in respects to this. And I'm going to paraphrase it. It was to the respect of, we are still at the point where we don't know what we don't know about the potential for this. We're still fumbling around in the dark, trying to throw AI at every single possible problem that we have and seeing which ones stick. Like, for example, we're now using AI to help with the tokamak reactors, and they're creating solutions for containing plasma that are far better than what we were able to do as humans. So that seems promising. But yeah, I think we are still just blindly shotgunning AI at everything and hoping that it'll make everything get better.
Yeah, that's true. I think I have to really agree to that. Yes.
Yeah, and these stages aren't sequential either, right? Like I think that you could experience simultaneous conflicting emotions about AI, right? Like you could say, I am super sick of hearing about it, and then use AI to help sum up an email or write a cover letter or critique your
Mhm.
resume based on a job description or something like that, right? So
Hmm. Yeah, that's true. Yep. Even parts of these presentations was even a couple of things were generated by ChatGPT, so I wouldn't really deny that I have not been using it. So that's true.
Are you an AI, Vivek? You have to tell us. It's the law.
I knew it. I knew it.
So
He's replicated
I think I have
himself.
to do a.
Okay.
We might never know, and maybe I have to do a captcha to prove myself that I'm really a human.
That's why you weren't so worried about staying up so late. You've created an AI replica. You're actually
Yeah.
asleep on that couch behind us, and you've managed to computer vision. You're so clever.
That's true. Maybe. Hi, Vivek. They actually found us.
Busted.
So yeah. So it's 6 a.m. here, and yeah. So early morning over here.
I appreciate you for this.
And
Indeed.
yes. So coming to computer vision, I wanted to really take a case. How did really computer vision gathered interest over the time? How did it really mature? And that will give us a sort of a benchmark to see how much is generative AI at this stage, and could we really compare it, or what's really heading it for us right now? So if you take computer vision, so the innovation trigger was way back in 1960s or 70s, or even more before that. And that's when they were able to do some basic tasks of edge detection and so on. And one of the key event which made it much more popular was about the early phase detection, and that was properly used. So Teiko Kanade, I'm not sure if I'm pronouncing the name right. So he was a person who was behind the first the face detection algorithms that came into picture. So that triggered a lot of interest. People started to see if we could be able to apply that in various use cases, or how it's going to really shape up the world. And that piqued the expectations. So after nearly 30, 40 years of research and everything, the biggest breakthrough which actually enabled or pushed computer vision to another level was through CNNs. The way how it learned the images, or way it tried to learn the vast dimensions of data. So CNN was really good at that. And the key milestone was around in 2015, where we had a lot of models coming out. So we had ResNet, we had MobileNet version coming out, and we also had a lot of other ImageNet as well. So there were a lot of models which came out, and that really gave a boost to the whole computer vision domain. People started using the train model to imply to their own use cases, started using transfer learning and a lot of other things. So then we had a lot of privacy and concerns coming around that. So what happens to the image which gets captured, or how it's being handled? Or if you take one of the popular use cases was the self-driving car, and people were very much concerned about how what happens when accident comes into picture, and who's responsible if a self-driving car meets an accident with a human or with another car. So that's where a lot of debates went in, and a lot of bias and privacy violations were really put forward. And then, if you really see where we are using computer vision on daily basis, is where we are using it for traffic, we are using it for retail purposes, we are using it for healthcare. So one of my early research paper which I worked in, I think it was 2016 or 2017, it was basically trying to understand the mitosis cell, which actually the cancerous cell in which was captured from breast cancer. So that was one of my early research papers, and that was when the peak of ResNets and other stuff was going into stuff. So people were really using it for right use cases, and the security surveillance were a huge hit, and people really loved that. And one more thing, I really never experienced it, but if you guys have experienced Amazon Go, where you could just have a checkout free experience, but if I really wanted to try that, how it really works. So that's something. And right now, I think it's been adopted pretty wide. So as I said, like a friend of mine sent me a video of even a driverless car, which was really fascinating to me to really see that it's really working, and something like that. So computer vision has gone through a lot of hypes, a lot of expectations were set, it was even being pushed down with all the issues that it came up with, and it really settled down in a fact that is really helping our lives in some or other way. So if we compare that to generative AI, where are we right now? So though this generative aspect has been with us for a long time, 2014 was a very keen breakthrough, is where we had GANs, one of the very popular sort of a neural network where it tries to generate content, not content actually, it tries to discriminate and then generate another version of the same data. So that's when it really got a bigger vibe. And GANs were very popularly used back then for deepfakes. So uh, I think it was 2016, and it was my freshman year of my university. And we had very little access to GPUs. But the first video which I created is that it was Obama talking about something else which he was really not doing it. So we had to spin up a GPU, run it throughout the night to create the deepfake of for 15-second video, and it was pretty cool. So we were showing around to my professors and to my friends to see this how it really works. Though it was really bad, like there was disfigurement in terms of the facial figures and so and so, but still it was a very fun activity. But yeah, this is just I was telling in my side, but a lot of research and other stuff was happening on the other side, right? And it really inflected the expectations when uh, your large language models came into picture, and your generative pre-trained transformers were really a hit. So these models were able to provide human-like text and even some images and code. And with the launch of GPT-3 by OpenAI in 2020, that's when people tried to see that, okay, there is something huge which is going on, and they wanted to adopt it to their businesses, their use cases, and much more. And since the research went into sort of an initial consumer testing part, and that's why people try to put a lot of concerns. So even right now, we are very much concerned about the bias it creates, the hallucination it creates. Yeah, of course, we know that we could control it and everything, but still, that is something we need to be really worried about. And this is something that we need to keep maturing it so that we can adopt it to the right, comfortable use cases to really assist us or bring us more values. And yeah, so that's where we are right now, tumbling. Maybe not true. Maybe after a couple of months, the opinions might change. But let's see how this comes into picture. So around 2026, it is expected that more than 80% will adopt generative AI. But 2023, it was just very less than 5%. So I think the adoption is increasing, but the success comes through when we adopt it to the right use cases, as we also saw in the example of computer vision earlier. So maybe this is an open challenge. Like this is what I've been seeing in 2024 at least. If you could find a tech conference without a generative AI keynote talk, do let me know. I'll be happy to see what that conference is offering. So whether it be it any tool or any service or any provider or any infrastructure provider, everyone talks about generative AI, and it's part of their uh, big concern, or they wanted to put that in spotlight, right? So if you guys find something, let me know. I'll be really happy to take a look at that. So
yeah, I wonder if you have to like go entirely out of the tech industry, right? Like, do you need to go to like the concrete conference or something like
The
maybe
Canoe Makers Conference, I believe, doesn't have a keynote on generative AI this year.
Yes.
So yeah, that's true. So maybe in 2024, we will try to find more practical use cases, more refinement of use cases and such like that. And that's where the generative AI might become more mature. And probably this aligns with the Gartner's prediction that it will be adopted to more than 80% of enterprises. But still, it's all opinions and facts. Things might go at any pace as we move forward. Let's see how things come up. And what is AWS is doing with generative AI. So a lot of talks have been going on. Even if you go to reInvent, a lot of talks have been towards generative AI. Even my talk as well. So in a way, yeah. So let's see what AWS is really offering us. But I'll promise you that this entire session is not about talking about what AWS offers over generative AI. We are going to go to something different. But before going to that, we see that okay, we have Amazon Q. And you can actually chat with Amazon Q. You could you can integrate that with your IDE. If you use Visual Code or something, you can ask it to explain the code. You can generate the code. It can help you with the documentation, a lot of other stuff. And also, it scans for vulnerabilities as well. So, have you guys used any code generation tools? At least given a try, or maybe you are using it for day-to-day purposes?
Oh yeah,
Daily.
absolutely.
Yes.
Yeah.
Oh, okay.
Every day.
Every day, yeah. So we have Amazon Q for that, and Amazon Bedrock is a fully managed service for you to play with, build LLMs, deploy it, and customize it for your use case. So you can pre-train, you can fine-tune, or you could add agents to it to orchestrate a couple of flows. You can even bring in your own data or your enterprise data or your private data and create a knowledge base and ask LLM to retrieve the information from it. So that's also a possibility. And you could control the user's input and your LLM's output with a couple of guardrails. You can set which topics to talk and which topics not to talk about, what sort of words that you need to really prevent the LLMs to be putting out as an output, and a lot of other things. And the whole infrastructure for you to train and do inferences and everything. Yeah. So that's what AWS offers us right now in generative AI. And 2024, it has been the first time leader. So I just came across this particular news article while I was reading about it, and I thought like, okay, so AWS is focusing on it, and maybe we also want to just be aware of what's happening around. So now comes one of the core aspect of this today's talk is that I wanted to go back and talk about the AI ML services that exist in AWS. So the idea behind that came from I've been listening to a lot of talks, conferences. I've been attending a lot of conferences in India, virtually in a lot of other conferences as well. I really miss the topics where we talk about how we could take the model to production, what are the nice best practices you can employ in ML ops, or what are the new AI services capabilities that comes into picture? How did the no code tools really improve over the time? To my surprise, that I have not actually used the no code tools in quite a while. And while I was doing some experimentation a couple of days back and today, and even before this presentation, I was surprised to notice that there have been a lot of improvements. And I was not aware. Maybe I'm not much more inclined towards reading news, but the thing is, it's not being put into the spotlight that we are not really aware of what's going on the other side of generative AI. So maybe this talk is going to be a refresher. Like, hey guys, like if you wanted to start with AI ML, what's really there that you wanted to start about? So that's what we're going to talk about today. Not much of a code aspect, but it's really going to be a good refresher talk for anyone who's tuned in.
Okay.
That's great. So ML stack, we have AI services. AI services are like Amazon gives you a pre-trained models that you could just call, and you can customize. You can call it via an API and integrate with your applications right away. That gives you more time to focus on your business use case and use your AI models for already predefined use cases. So that you could actually make your whole ML flow or your AI flow very easy for the use case. So we have a couple of AI services for that. We'll just take a quick look when we deep dive into it. And now comes the Amazon SageMaker, which is like a fully managed service for a lot of things. So we have Canvas, which is a no-code approach. We will take a look at it as well. And we have your Studio. Studio gives you a lot of features like data wrangler. We have projects, we have Jumpstart, and we will also take a look at how the console looks like and everything. And the layer below it, the infrastructure, yep, we have a lot of models which have been available for us to pick and use, and to run our machine learning models, to train the machine learning models or run inferences. We have EC2, we have GPUs and CPU support, we have Trainium for training machine learning models, and Inferentia for especially for deploying your models for inferences and stuff like that. So today we are not going to cover every single thing, but we're going to just pick out few interesting stuff from all the levels and see what's been going on in that trend.
Sounds good.
And this is something which I've been quite asked very frequently, like, yeah, your generative AI does text summarization. Your generative AI does entity recognition, or if you pass an image to your image related foundation models, it can really give you more insights about or talk about that image as well. Or you could also make it as a text to image aspects. So now comes the question. What is the thumb rule that you wanted to keep to choose between a generative AI model or a predefined or pre-trained AI services which is already available? So my answer towards that would be, if you have something very creative and it really requires you to generate something from the existing knowledge, your best choice is to go to generative AI. But if you drill down your requirements to a level that you understand the use case or you're trying to solve, or the problem that you're trying to solve is something broken down into a couple of sub problems, and few of the sub problems is already available as a managed service. For example, if you wanted to if you want to do a facial detection, you don't really have to use a generative model to do that for you, right? So you could go and use an AWS recognition API and make it much more easy for you. So when we need a quick, scalable solution, and for most standard AI tasks, that's when you have to go for AI services. So maybe when you next pick up your side projects or start working on a new use case for your company, this is something that you could keep before going into that aspect. And not just that, it's more complex, that you actually do some favor to environment as well, right? So training your LLMs is takes a huge lot of compute, which really takes a dent in nature. So I think you have to make a very sustainable approach towards choosing generative AI models. So what do we have in AI services? So pretty much standard stuff, like we have comprehend for natural language processing, the sentiment analysis or topic detections, topic modeling. We have translate for translations, and transcribe is speech to text, and text to speech is your poly. And we have recognition for all object, scene, facial recognition from both images and videos. And if you have any forecast or demand forecast or related to that, you could use Amazon Forecast for all time series based problems. And you could use Lex to build chatbots, and you could use Personalize to create real-time personalized recommendations. And Textract is more like OCR, so you could extract text from tables, forms from scanned documents like invoices and stuff like that. And Kendra is an amazing intelligent search service. So you could actually uh, search to unstructured data using natural language queries. So this is something that you could also consider if you wanted to be an alternate, not an exact alternative, but a slight alternative to knowledge bases if you wanted to keep. And we have Amazon Comprehend Medical. So it is an same as Comprehend, but is more focused towards the medical aspects towards that. So it could give you more very good information about the medical related insights and information from a clinical text. So maybe if we wanted to see a couple of examples, I will just show you through the console for the interest of time. You could also explore it from SDKs and APIs as well. So if we go around that, I'll share my other screen. So Yes. Let's go back to my console. I'll share my screen right now.
And one question I had while we wait to flip back, do you have any thoughts or thoughts or tips for someone who's trying to get started with playing around with AI, learning it in terms of, you spoke about compute power. I'm thinking, would your recommendation be AWS using their tools? Or, I have like a lot of friends who actually take and they equip their actual home rig. I haven't got to that yet, but they're buying, like their own GPUs and stuff like that. Like, what are your thoughts about that?
So if you are trying to start new, so there are a lot of basic models that you're right now our computers and our PCs are really powerful to support basic models. So just go ahead, go to Kaggle, download a working notebook to run it locally. And there are a lot of services which offers you free GPUs, free CPUs. For example, Kaggle again. So you don't really need to have a cloud provision infrastructure to get started with AI ML. And if you wanted to try some advanced models, or if you're trying to build some small side hustle projects, and you don't want to invest a lot of time into creating an AI model, but you want to integrate those capabilities of it, then you have to really choose AI services. And you're just going to be paid just by the usage. So if you're mindful about the usage and if it falls under the free type, you are still good about that. And if you really want to even push to another level that, no, I really want to use cloud and now you have to let me know what should I do. Yes, you could go to SageMaker, you could spin up a notebook, Jupyter notebook, start running some models, maybe try running a CNN, train a CNN, deploy it and see how that goes. And that should be one of the basic starting points on different levels. So beginners, feel free that the AI, or if you're really going to start with AI ML, there is no constraint that is keeping you at the moment in terms of the physical compute power and something. So you're always good to get started immediately. That's something that I would really, I really, when I talk to students, I emphasize that about it as well. And AWS also offers free trial, and so does a lot of cloud providers as well. So if you are falling under the free trial, and if you could uh, go and explore, that's pretty much awesome. Yeah. So if you go to recognition, so we have a couple of use cases or some couple of features that it offers. Like here we have a man skateboarding in the middle of the road. We're able to find what sort of the image has. So we have city, we have a road, we have a person, and what sort of request which was sent, and what is the response that we got from that. And maybe if we wanted to go and see the other image, if it looks like, so we have architecture. It's also able to segment each thing over here. So we have tower, so we have a sea, we have building, we have it's an urban cityscape, and so on. So you could also try by uploading your own image if you wanted to play around and see how that goes. So does your facial analysis. So it detects whether what's the mood of the person and what's the age of the person that the person featured in the image, and more than that. So if you go to celebrity, yep, so it's Bezos, and it's able to recognize it much more easy.
I don't know. I feel like putting in their pictures is just cheating. I mean, of course it should
Should
be
we try
Andy
Chris pictures?
and Jeff. Yeah.
Yeah.
Yeah, it should be someone else, you know.
Let's try. Let's try. If it gives that I'm not really a celebrity, I think we have one here, right? So let me try that over here.
Like I swear, if someone at Amazon is like, we better make sure that it can recognize Jeff.
Yep, you know they did.
That's in the requirements. You know, that's like on page 7 of the 6-pager.
Okay. Oh, it should be hosted in.
Celebrity. I don't know if
I
Andy
think that
Jassy's
should
a
be there.
celebrity. There we go. But do you know Vivek? That's what I want to know, AI.
Yes.
That's what think of it. So let's go and see. It's trying to read or not. Not sure. Maybe I
So
could download my image and send it across. So that's more easy, I guess.
It might not be able to go and retrieve it.
Uh-huh.
Sorry for
a lot of hurdles.
For the diversion here.
Way to derail this, Damien.
Good Lord. I think I'm great at that. I should put that
ruining it for everybody.
Chief derailer on my headline.
We have got the picture. It should definitely say I'm not a celebrity. I think then the model should work. So no celebrity face is recognized. I think we are pretty much good. The model is suggesting at the moment.
Okay.
It knows Jeff and Andy. I guess that's good enough. Whatever.
Yeah.
So text in the image, so that also is there. And this is something what sort of protective equipment that the person is wearing. So it shows face cover, which shows head cover, and so on. So if you now go back to the old vBrownBag episode of mine, you would be actually seeing how I'll be using this Amazon recognition, the PPE detection, to see how is a person wearing a mask or not. So now comes the question, the answer to your question that would I have built an image recognition model to detect face masks and deploy it and use it, or would I made a right decision about using the existing model and focus on my use case for that? So I think I chose the latter part and it pretty much worked well. So I could work much more as a better use case. And it worked pretty much. So if I was really working on my own machine learning model, it's my responsibility to make sure that the accuracy is pretty much good, or if it's not, and stuff like that. So yeah. So we have something around something like this. So we have recognition if you wanted to go around comprehend. So yep, maybe just comprehend we will see. So the built-in text, it recognizes, or maybe I could just go and I actually pasted my bio so that I could paste this as a input text to see how it works. So if you see over here, I'm going to make it custom. Okay, built-in, and the text is this one. So here, I'm going to give analyze, and let's see how good it does. So, yep, Vivek Raja is my name. The organization is Nextem. Your story is, yep, it's an organization. ML Hero is a title. Pretty much it works pretty well. But yeah, Madurai is not a person. Madurai is my hometown. So, but yeah, it's something which is not really good in a way. So coming back to our presentations over here. So we have a couple of AI services. The thumb rule is that you go and choose the ones which is much more convenient to you, that is more standardized and works for the use case. So going back to my presentation here. Yeah. So we have Kendra, we have Comprehend Medical and stuff like that. So now let's go back and see a couple of the core machine learning concepts that we have. So if you want to break any machine learning concepts or any machine learning problem, you deal with 4 steps. So the first is to collect the data, and then you train it, then you validate it, and then you see how that results work. So the first step is to, even in collection of data, you have to identify the data sources, you have to collect the data, then you have to do a lot of pre-processing like data transformation, you have to clean the data, you have to understand the data in such a way that you could make some domain-related decisions. And once you feel that the data is really clean, that's where you take it to model training, and even there you try to tune the model by hyperparameter tuning and see which model really works for you. And once that is done, you still go in a cycle of validating with the test data set. If the model is performing very poor, you again go back, retrain the model with better parameters and come back again, or even switch the other model. And once you're pretty much comfortable and you're happy with the results, then you put it out for prediction. But that's not where the job really ends. So when it's out there in the production environment, you will still keep an eye on how the model is predicting and how the accuracy of the model is over the time. If you feel that it drops below a particular threshold, then it requires a retraining of the model, and that's where we make such decision as well. So now comes the question like, how do you monitor that machine learning models, or how do you maintain data sources, or how do you enable your organizations to maintain data sources, maintain models, maintain versions of models, and stuff like that. So that's where the concepts of MLOps comes into pictures. So you bring data science, you bring data engineering, and you bring data DevOps practices together, and that gives you your machine learning operations. So what all you do here in data engineering, you keep the data management, you try to see how to stream the data to the cloud, or you maintain versions of data, versions of the processed and pre-processed data that you have. And in data science, you work with improving the algorithm or choosing multiple algorithms and then see which algorithm works for you, and you tune it to another level to see if it gives you the right results that you want. So your model profiling and your model management comes into picture. And DevOps practices helps you to, once you finalize your machine learning model, how do you going to put that into production, or how are you going to monitor your model in production? Or how are you going to set some pipelines that could trigger and give you training results without having to do it manually every single time? So you bring in the concepts of software development, software engineering concepts, and CI/CD and release-related practices into machine learning, and together it gives you machine learning operations. So yeah, it really helps you to improve your team's efficiency. So, which I have personally seen in my own company when we were trying to do a lot of research work for neuroscience. So basically, you get started, you name everything as experiments. An experiment is like you keep an objective of accomplishing something, and associated data and the models related to that experiment, it's retrained, it's trained multiple times to see which model works for you. You maintain the whole profile of it, and once you pick, you can actually pick and place which model to go to production or which could do the testing part, and you do the whole job again and again through pipelines, and you try to achieve the MLOps over here. And this is something very interesting. So I've been helping a couple of startups. I've been also implying this MLOps to my own organizations. I feel that there's 5 stages of how people first embrace and adopt MLOps, which they have never seen before. The first thing is, I would certainly relate this to the 5 stages of grief. So the first is denial. So people love to do manual. They're much more into the comfort zone. They don't really want to do adopt MLOps. You go to your machine learning engineer and say that, hey, do you want to maintain the versions of your machine learning code or your model? He says, no, thanks. I'm pretty much no. I have directories which really maintains that for me, or I use Git. That's the answer which I get. So everybody has MLOps, but here I am just doing things manually. So people love to do that. They don't really want to push out of the comfort zone. This is when mostly I've seen this in early stage startups, and then they go to the second one, and you then start working on setting up the infrastructure. Like if I want to train this model, you go and fight with the IT team to provision such and such instances for you, or you go and request your manager to do that. And then the whole pipeline about setting up the environment and making sure your machine learning model can train or deploy, you do that again and again. You really losing the focus of working on your machine learning problems rather than you start working on the infrastructure problems over here. Then goes to bargaining, right? Then the machine learning person comes and says that, hey, see, I tested this in my local machine, it works. So if this is not really going to work in the production, that's not really my problem. And that's where the whole fight comes into picture. And it's always the blame game that comes with it. Then finally, people try to subtly understand that, okay, there is something that we need to adopt as a framework, as a process to make sure that the research, the data science teams, the engineering teams comes together to solve a problem. And finally, they go ahead and accept. So you try to bring the production more close to research. So once you enable that, your research becomes much more efficient, and you focus more on solving the problem rather than trying to actually start working on the problem itself. So that's how I identify the 5 stages of adopting MLOps in any organization at first. So overall, you try to make it much more efficient. You have CI/CDs, you have scalability, you can reproduce problems as well as models, or the whole the setup or whatever it is, and you give much more collaboration across teams. It can be one machine learning team or multiple machine learning teams, or across other teams as well. You give access to your DevOps team, you give access to engineering team to work on top of it, a lot of other stuff. So this is how now we have seen we have AI services in AWS, and then we also saw what we really do besides generative AI. Like we do machine learning, core machine learning stuff. And I wanted to take you quickly through SageMaker Studio and see what it really offers. And we might have a quick demo of doing something. So again, let me go back to this one. So before we go into SageMaker Studio, we have something called projects. So the whole MLOps can be created, which we saw as an experiment is called a SageMaker project, and you could organize your code repositories, you could organize your CI/CD pipelines, and you can give accesses and everything over there. And you could also maintain the whole model registry and data sets and pipelines. So not much of a focus for today, but this is something that you could go and see how it works for you. So let me take you to my console again to see how that works. And next, we are going to something much more hands-on. Stay tuned to that. So we are going to SageMaker Studio, which looks something like this. So you have projects, and this projects is where you go and try to create a project for MLOps. So once you try creating a project, you will be able to create a code commit. You have predefined templates, like do you want to just do model building and training, or you want to do model building, training, and deployments. And as of now, we ensured that last month, AWS is not much more supporting the templates for projects. So you have to use third-party Git repositories for much more project templates. That's a little bit of a bum. So that's the reason I didn't want to go much more focus into projects today. But let's go back to something, to the first stage of doing machine learning, right? So we talked about MLOps. We also talked about what are the 4 stages of machine learning goes into picture. So today I'm going to show you how quick and easy is it for you to get started with machine learning, and especially you could take the data from scratch to a deployable machine learning model. So to understand that, let's again switch back to the presentation again. So the first stage which we saw is about the data pre-processing, and that what is we call as data wrangling. So it has a lot of tasks about when you have a data represented as a table or something. There is a lot of possibility that it might have missing values, it might have incorrect values, and when you combine that a lot of data from multiple sources, the data types, and there is a lot of inconsistency which can occur. So once you pull in the data, you try to pre-process and clean the data so that your machine learning model can learn the data much more better, right? So the whole goal is to prepare the data for machine learning analysis, for machine learning models to work on analysis, so that it makes it much more easy for it to learn. And this is what I wanted to show you with Amazon Data Wrangler. And right away from it, we will also see how we could make it to the deployment level. We could train and deploy that as well, right? So again, going back to the console again. So Right now, the Data Wrangler is available and it is right now part of SageMaker Canvas. SageMaker Canvas is like your no-code platform. So once you go here, my canvas is already open. So I'm going to my canvas right here. So yeah, spoiler alert, I've already showed the accuracy, but let's try to do it again. So we have a lot of predefined data sets, but let me show you how to do stuff. So I'm going to go with a very, very typical data set, which we already find it. It's the Titanic data set. It might sound gloomy for a early morning person like me because it's going to predict whether the person survived or not. But yeah, let's try and see what it has. So I'm going to upload that from my local machine, and it's going to take a couple of time, and I'm going to upload it. Yeah. So you could preview it, and you can do a few things, or if you feel that it doesn't have a header, you can not do that, or you could give it as a header as well. So it depends on how you have formatted the data before. Once you create the data sets, it's available over here, and it takes some time to get it uploaded and does some initial stuff. So now I'm going to take it to a data flow. I'm going to uh, pre-process the data in a much more efficient way. So the first thing I'm going to do is I'm going to add some transformations to it. And I realized that you could actually talk to an LLM to ask insights about how you could clean the data. So we could even start with it. That's something pretty cool. So though I wanted to move much more away from the GenAI spotlight, it's been everywhere. So why not give it a try? So what I'm going to do is, let's assume you're pretty much new to machine learning. You don't know what to actually clean or what steps to take up. So you could still use get data insights, or you could chat with an LLM model, and you have to actually enable the model before you go to it. So let's see that. I'm going to type that analyze the data set and give the columns which can be safely removed. Which doesn't contribute to the target variable. So the target variable is whether the person survived or not. So that's a target variable over here. So which does not contribute to the target variable survived. Right, yes. And also find the features which has missing values. Yeah. So if I give this prompt to this machine learning model, it actually uses Anthropic's Claude model, and you have to give some model access before you enable it. And again, I when I first tried this out, I really had some. I found something thing. So it shows that your passenger ID, name, ticket, and cabin can be safely removed because that doesn't really contribute to the target variable survived. And age has 19% missing values. So that's a good insight. We could start with it. So before that, let's see, passenger ID doesn't really contribute anything. So does your name, so does your ticket. Your ticket really doesn't matter anything. And next is cabin. So cabin can be also represented from the passenger class, so that is more important than the cabin itself. So cabin's thing doesn't really happen. So let's go, and I'm going to manage columns, and I'm going to drop a couple of columns which it suggested. So which is the passenger ID, cabin, name, and ticket. So when I give it, it's about add. So it does the pre-processing. And it also suggested me that go and fill the missing values from age. So what I'm going to do is handle missing, and I'm going to select it as age, and I'm going to make it as a mean value so that it works pretty well. So the next thing is I have noticed that there are the fair amount, which really does not contribute whether the person survived or not, right? So that is where the machine learning model really failed to find out. So again, now comes the real aspect. So do you want to really trust the answers? Not fully. It really helps us, but here, since I already have a domain knowledge and worked on this data set before, I knew that the fair does not contribute anything. And a person who have done data exploratory analysis before going into this aspect might have found that issue. So, which means do not fully trust the responses. So that's something which I wanted to also emphasize. So again, I'm going to manage the columns and then I'm going to drop fair, right? And also I'm going to, if you see, there are some string and I could make it as a numerical value. So it's called encoding categorical, and I'm going to give that as embarked as well as the gender. So if I do that, it's much more easier for machine learning model to learn it. Yeah. So I think now my data is pretty much cool. So it's easy for, oh, sorry, I've given us backspace. Okay, let me go back here. So all this has been done. I'm going to run this validation. There's no errors. So let me go and train a model. So I'm going to create a model. It's going to be predictive analysis, and the target column is survived. So now comes the picture. So if you are a machine learning person and you wanted to do it from scratch, you decide what is type of a problem it is. So since we know it's a categorical target value, we know it's a classification problem, and then you try to choose which model works. So you might choose from uh, logistic regression to decision trees and a lot of other stuff. So you might try around 10 to 15 models, and each and every model you have a couple of parameters, hyperparameters. You have to tune it. So now comes something really amazing, which is called AutoML or automated machine learning, which itself parallelly tries with multiple models, multiple hyperparameters, and gives you the best model after doing it. And it has suggested that's a two-category model, and F1 score is much more preferred for classification problems. I'm going to give a quick build. It's going to take a couple of time. So instead, I'm going to my models, and I'm going to show you that what really happened in the previous this one. So it gave me a 80% accuracy for the same thing, and the F1 score for 0.737. It's a decent one, not a really great one. I could now go ahead and deploy it, predict it, or even more go for a much more extensive training as well. So without even having to start coding, you could actually test around multiple machine learning models and see which really work for you. So that's automated machine learning. And let me go back to the presentation again. Yes. You can build machine learning models with no code. So automated machine learning is now part of Canvas, and it's also the last step of Data Wrangler if you wanted to take it to the next step again. Yeah, it is available. What it really helps you, like if you're a person who wants to work on some complex problem, but you don't know how to start with machine learning, or you don't know what all models to be aware of to search it or to experiment with a lot of things, AutoML is a really good friend. Though it does not really give you a very good accuracy, it does a pretty much a decent job. So again, now if you come back to this thumb rule, now you are pretty much aware that you could use AI ML services when you wanted to, AI services when you want to have a quick standardized tasks. And if you wanted to go for much more customized and focused and more accurate machine learning models for particular tasks, go for building your own machine learning models in Amazon SageMaker. Or if you feel that you're going to create something or generate or you're going to use it for understanding the natural language in a much more better way, I think that's where you have to use generative AI. So now it makes much more sense for us to know when and where to use Gen AI without having to peer pressure us to use it in our projects or use cases. So if you want to do deep dive into generative AI to understand how it works from very basics, so there are two videos part of a boot camp. One is on the introduction to AWS and generative AI. It's almost a 2-hour session which covers all the basics, and another 2-hour session which covers you about all the things like it covers you about the agents, it covers you about knowledge bases and guardrails and model evaluation as well. So you could try check it out. It's a very good starter if you're going to start with Gen AI in AWS. And yeah, so what's your guys' take on that? Will generative AI replace jobs? Do you think that's going to happen?
It's going to change the way that people work, and I think that bosses will try to make it replace people to try to save some money, and then hopefully they'll realize that it's not a good idea and that they still need the people. But I agree with that statement that's on the board. That is, the people that are going to be leveraging it are going to be much more productive, and the folks that don't use it or refuse to use it are going to get left behind.
Yep.
Absolutely.
Yep. And then I still feel like at the end of the day, just like when people were talking about like robots and stuff at one time, like you're still going to need people at some point to fix Gen AI, so.
Right. That's absolutely true. And
you just always
even if
kind of
you
need
take
that human element sometimes. So
yes, I think we as humans could never lose that element in advancing the tech in any way. Yeah. So we have unmanned vehicles, we have unmanned stuff, but it's still a human which creates it, or it's a human which drives it to achieve its potential. So that's always there. So this is something which I spoke about in a week before, a couple of days before. So which I wanted to also speak here, that what is something that we need to be aware of. So today we saw a lot of stuff. We dabbled around a lot of topics. We started around why generative AI is having a huge hype and what's really happening behind the screens. Like what's a research aspect to it, what's a consumer aspect to it, and what are we really heading towards. And then we also saw what are other services which are available in AWS that you could start leveraging for small workloads or for your particular use cases. We saw no code approach. We also saw how to streamline your organizations with MLOps, a lot of other things. So when I was giving a talk a couple of days back to a lot of C level executives, so we were emphasizing this. So me and another AWS hero, we were working on a presentation of generative AI and the ethical risk. But in today's talk, I wanted to really also emphasize on why we need to consider these risks and how are the ethical considerations are taken into picture. So first thing is bias and fairness. So we have to establish guidelines towards it. And there is always a take that the machine learning model is a black box. We don't know how it arrived as a decision, and I do not know how much I should trust the decision, right? So if your machine learning model can backtrack and give you reasonings about how it arrived as a decision, what are the key elements it took into picture, and then how it does, that's when you really bring machine learning much more closer to human to accept those decisions. So today, even we saw one such use case that the generative AI model is not able to understand that the fare doesn't really contribute to the survival aspect. So until we try to go and trace back the missed data like this, or it going to give me the reason behind why a passenger ID or a cabin number doesn't really contribute to your survival, that's when you try to bring the humans much more closer, and humans starts taking those answers in to imply that to solving problems, and it gives a lot of an accountability and ownership sense. And you should use, as everyone knows, be very sure that your AI applications follows the right ethical approach. And with that, it's also necessary for you to comply and follow regulations. So there are a couple of AI services, AWS services, which really helps you with it. So we have Audit Manager, we have Inspector, and so on. So to help you with audits and this one, how to manage your regulatory compliances. And one more thing is the environmental impact. So before you start customizing your foundation model, you have to actually provision a huge number of instances before you could start training. That really affects the not just on the training aspect, but also on the inference. So ask yourself a question whether you're ready to go for this big junk models to solve your use case, or you could still break down and go for some standardized models as well. And if you're actually following the right ML of principles, you still have a view around the observability part where you observe how the model works in the production, set up systems to give you alerts when it drops down on the prediction part, so it doesn't really trigger some unwanted consequences. And we also need to have, at least in the initial levels, to train the machine AI models to give more human feedback. So we have in Bedrock, we have human evaluation, and we also have in AI services called A2I, which is Amazon Augmented Intelligence, which is you could actually employ or you can bring in your own team, or you employ external people to benchmark whether the results are correct. So which is really good for you to evaluate how good your machine learning model is doing, and establish frameworks across your organization to implement a responsible AI stuff. As a leader, make sure that you are aligned with your business goal before you really take up AI. So there have been a lot of instances where people just sprinkle AI to their product and say that it's an AI powered product, where the AI really doesn't make any sense or really contribute much aspect to it. So first ask yourself a question that whether this AI really contributes to your business goals, and do you have the right data to train the machine learning models that is not having any bias and other stuff, and who is going to be accountable for the decision it makes, and how explainable and how transparent are the decisions are, and be very sure about the ethical, sustainable, and responsible use, and it always follows the regulatory compliance. And keep a check on the security, because the data breaches really does take a big impact, because it has a lot of information and it could be used for very wrong purposes. And that's it for the day. So today we spoke a lot of stuff, not much into the code, but we really went behind generative AI after a very long time, even myself, to talk about what is happening on the no-code platforms, how to streamline your MLOps, and what are the other services which is available for you to pick up and start working. So
Very
this is
cool.
my link. You can scan and can connect with me if you want to talk more about it. Yeah.
Hold on, let me put that right back up again real fast. Okay. And now we're back. There we go. Hey.
Yes.
Awesome. I saw how you smashed a ethics talk into the end of that. That was clever. That the talk about AI ethics. We actually had an AI ethicist come on the show, and that is such a fascinating and also disturbing field, because if you don't put the right guardrails around these models, you can deliberately make them be just absolutely awful, because it's based off of human interaction, and you can have good human interaction or you can have awful human interaction. And
Exactly.
yeah, some of the history that she got into was fascinating about how unregulated AI that was learning off of Twitter just immediately went into like 4chan mode, and it was just an awful thing. Vivek, this was awesome. Thank you very much for coming on.
Thanks so much.
Yeah, I super enjoyed
I have
that.
one question. I have one question for everyone. So
Sure.
now that we have generative AI models, right? So we have started generating content. The content is available in the internet. And let's assume we are going to create much more superior generative AI models, and you're going to feed the generative content as a training data set to it. So what happens when you try to feed such generative content to generative model training? Will that affect the prediction rates or how it performs, or it really going to improve? That is something we have to still think about.
Well, doesn't that also, I forget the term for it, model collapse? When you start circling it, is that the phrase you're looking for for this?
Yep. Yes, correct. So we might not really converge to a very good model at some point of time if we keep on feeding generative content as its training data set to generate more content. Yeah.
Right. Yeah. When it starts to eat its own tail. So, which means that there will always be humans necessary to inject fresh creativity into the system.
Absolutely. Yes.
So far, we'll see what happens. Awesome. Okay. Vivek, thank you so much for coming on. We're ridiculously over time, but it was totally worth it. This was really, really good stuff. Damien, Shala, any last questions that you had? I asked my questions as we were going along, but was there anything else that you wanted to hit him up with? I also want to make sure that he gets a good night's sleep. Or wait, wait, Vivek, you said that you were up all night. Were you up all night? And now you're. What's your time window here? How are you doing this?
So actually, I didn't sleep last night, and I went out. So I was working on this presentation. I was reading a couple of research papers, and at 5 a.m. I took out my motorcycle, went out for a ride, and grabbed some chai outside, and I came back and started with my presentation.
Oh my gosh, you're a machine. You are AI.
Vivek, they found out again.
As soon as I recline in my recliner to watch TV, I fall asleep. So,
and he's getting on a motorbike at 5 a.m. for chai.
Sure.
Yeah. Amazing. All right. Well, you go get some rest. We're going to do the exact same thing on this side of the planet. Thank you so much. Folks, thanks for listening in. Folks, have a wonderful evening. Vivek, I will see you in December, early December. Shala, are you coming to reInvent?
Yeah, I'm going to be there. You talked me into it.
We're all going to hang out at reInvent then together.
Awesome.
Yes.
I'll have to send a cardboard cutout of myself.
We're gonna make a little head. Yeah. We're gonna have a little
we can carry it around
to carry around with us.
I'm grumpy. Ooh.
Yeah. Oh my gosh.
By the way, I've never seen him grumpy, y'all. So don't even listen to that.
Actually, I've seen Damien grumpy. Damien and I go back. I've seen him grumpy.
I should have my wife join this podcast. She'll be like, "You just haven't seen Damien."
Girl.
Happiness is his that's it's his off hours when he's happy.
Oh boy. All right. On that note, have a wonderful evening, everybody.
Thanks, everyone.
We'll see you next week. Bye.
Bye.
Bye.